Alright, and welcome to simple, linear, and quadratic systems. Now, let's go ahead and underline the word linear in purple. And when we look at this graph that I give y'all, we know that a linear function is simply a straight line. Let me underline the word quadratic in orange. And we know that a quadratic function creates a parabola, or this U-shaped graph that we have right here. Now, in a linear and quadratic system, which is obviously a combination of the two things, we are looking, of course, where you would suspect the answers to be, where these lines actually cross. So for here, I just want you to pause the video and take about 15 seconds and say, hey, where are these 2 points? Go ahead, jot them down, write them down for your notes. Alright, and so we clearly see that this point is at -1, comma, -2. There is one of our solutions. And we see that this point right here is clearly at the point, let's see, 2, comma 1. Now, if we're given the graph, this is fairly obvious, especially if they're crossing at integer or perfect points. However, what if they're not crossing at perfect points, or what if you're not given the graph? How would we solve this? Okay, well, let's go through this in steps. Step 1. Given that both of these things are set equal to f of x, or aka they're both set equal to y, the same thing, we can actually set them equal to each other. So, step 1, we just want to set these things equal. So we can go ahead and write -x² plus 2x plus 1 is equal to -1 plus x. Now you'll notice that, hey, this is fairly messy. So what's our solution here? Well, whenever we combine a quadratic and a linear function, notice that the highest degree, or the highest power, is still a square. So ultimately, when we set these two things equal, we are given a quadratic problem, let's say. So what we want to do is now set this equal to 0. Remember, the way that we solve any sort of quadratic is set it equal to 0. Okay, so in order to do that, we have to determine, is it easier to move 1, 2, 3 things, or would it be easier to move 1, 2 things? And in my opinion, you should always treat this like luggage. Would it be easier to carry 3 suitcases up a set of stairs, or 2 suitcases up a set of stairs? Obviously, it would be easier to carry 2 rather than 3. So let's move the -1 on the right, and we get rid of a -1 by adding 1, and we get rid of a positive x by subtracting x. And when we do that, what do we get? Well, we have to add 1 to this side, and we have to subtract x over here, and let's write out our function. We have -x², 2x minus x will be plus x, and 1 plus 1 will of course be plus 2 is equal to 0. Okay, interesting. Alright, now what are we going to do to solve this? Well, I noticed that the x² is negative, so what I'm going to do is I'm actually going to factor out a -1. So say, okay, -1 parentheses, that x² becomes positive. And remember, when you factor out a -1, everything just switches signs. So positive x becomes a negative x, and a positive 2 becomes a -2 equal to 0. Now, of course, since my a term here is 1, let me draw this in red just so you know it's, I'm highlighting it. Since my a term is 1, I can attempt to simply factor these things. So what would that look like? Well, I'll break this down into 2 factors equal to 0. And we know that x² breaks up into x and x. Now, don't forget about this -1. He's still hanging out here in front of everything. But then we have to ask ourselves, what 2 things multiply to be -2 and add up to be -1? I'll say it one more time. What 2 things multiply to be -2 and add up to be -1? And I would argue that that would be -2 times +1. And you can check that out for yourself. Now from here, to finish this off, to solve for the x, what do? Well, we're asking ourselves what value of x makes each one of these factors equal to 0. And we actually know that x minus 2, the opposite of -2, would be +2, comma. the opposite of positive 1 would be negative 1, and here are our two x values. And notice that negative 1 as an x value for our first point, negative 1 is right there, and positive 2 for our x value is right there. Now typically in a quadratic function, oh, and by the way, I should have written this, step 2 is basically just solve, but there is a step 3. Notice we're not looking at the x-axis. Positive 2 and negative 1, it's not good enough to stop here. This is what makes these problems just kind of an added layer of difficult. We actually have to go back and evaluate both of these x's to find the y values. Pause this video, finish taking the notes, and let me clean this up for you. Okay, so a little bit cleaner now. And we see that x was equal to negative 1 and x is equal to positive 2. But once again, that's not good enough. So what do we have to do? We have to evaluate one of these functions at both these points. Now, I would encourage you, so let's write this, step 3. Let's just say it simply, plug in x to find y. And I would choose the easier equation. I would always choose the linear function. You don't have to, but I would. And so I would just say, f of x is equal to negative 1 plus x. And I would actually write it twice. F of x equals negative 1 plus x. And I would write it twice because, remember, we have two x values that we have to evaluate, negative 1 and positive 2. Okay, let's see what happens when we do this. F of negative 1 is equal to, well, negative 1 plus negative 1 is negative 2. And this gives us the point negative 1 comma negative 2, which we see is right there. Over here, we'd say, f of 2 is equal to negative 1 plus 2, which is positive 1. And so this would give us the point 2 comma 1, which is right there. All right? And that's how you solve a linear and quadratic system. All right, let's move on to a second example. And we'll move a little faster this time. Okay, so in example 2, we want to solve the system below. And by the way, let's just take a look. I give you the graph here. Where do you think the solutions are? Pause the video. Write down where you think the solutions are. Well, of course, you can see that they are here at negative 8 comma positive 1. And they're down here at what appears to be negative 2 comma, let's see, 1, 2, 3, 4, 5 comma 5. All right, so these two should be the two solutions that we work out when we work this out by hand. All right, let's kind of speed run this. We know that they're both set equal to f of x, so we can set them equal to themselves. So we have 1/2 x squared plus 4x plus 1 is equal to negative 7 minus x. Now from here, we know the highest degree is a square, so we want to set this equal to 0. It's easier to move two things rather than three things, so we can go ahead and add 7 and add 7. We can add x and we can add x. And remember, I'm simply doing the opposite. The opposite of negative 7 was plus 7. The opposite of negative x was plus x. And this allows me to zero out that right side. And now we have 1/2 x squared plus 5x plus 8. Now, if I'm given a fraction in the very beginning, this 1/2, I could, of course, use completing the square, or I could use the quadratic formula to kind of easily finish off this problem. But I would argue it's always kind of nice to, to kind of ask yourself, can we use simple factoring? So how do you get rid of a fraction? Well, you always get rid of a fraction by multiplying by the denominator. We see that the number here in the bottom is a 2, so I'm just going to multiply this whole thing by 2. Now, 2 times 1/2, the 2's cancel, and we're left over with 1x squared, which gives us a nice simple quadratic. Okay, 2 times 5x will be 10x, and 2 times 8 will be plus 16. And of course, we'll set this equal to 0. Well, once again, I see that my a term is 1, so let's try and solve this by using simple factoring. Okay, so I break this down into two sets of parentheses. And let's see, we know x squared breaks down into x and x. And what two numbers multiply, I'll say again, multiply to be 16 and add up to be 10? let's see, can you think of two numbers that multiply to be 16 and add up to be 10? Well, I would argue we could use 8 and 2. 8 times 2 is 16, and 8 plus 2 is 10. Now from here, remember, to evaluate x, we're looking for where x makes each of these factors equal to 0. So you just say, well, what's the opposite of plus 8? Well, that's going to be negative 8, comma, and what's the opposite of positive 2? Well, that's negative 2. And so far, let's see, so far, so good. Now remember, how do you find the y values? Well, you got to choose one of these functions and plug it back in. Of course, I would argue you should always use the simpler function, so let's just test out this one. F of x is equal to negative 7 minus x, where we're going to first test out negative 8. Okay, we know that two negatives here make a positive, and we could say, you know what, f of, oh, I'm sorry, I want to do this in orange. Say f of negative 8 is equal to negative 7 plus 8 is 1, or our point is negative 8 comma 1. And let's see, does that match up? Yes, that checks out. Okay, let's go ahead and check out our second one. Let's go ahead and check out our second one. Let me find my eraser. Interesting. Okay. So let's go ahead and check out f of negative 7 minus, oh, and let's go ahead and test out our second x value, which will be negative 2. Okay, we know that two negatives make a positive, and working this out, we can say f of negative 2 is equal to negative 7 plus 2, which is negative 5, or our point, negative 2 comma negative 5, which, of course, also checks out. Now guys, I know that this is a long video right now. I've given you two very easy problems, but I haven't used any difficult versions of factoring. So I'm just going to go ahead and do one more example, and you can count this next one as like a bonus example. If you still don't understand this, continue to watch, but if you feel like you got this, go work on the problems, and then if you get stuck, come back and watch example 3. You know, this next example is just more for your help if you need it. Okay, and here is example 3. Now, of course, we know that step 1 tells us that we're going to take these two things and set them equal. So we say, oh, okay, negative 2x squared plus 4x plus 3 is equal to negative 2x plus 3. Now, from here, we know it's easier to move two things rather than one, so let's go ahead and add 2x to both sides. Let's subtract 3 from both sides. Let's see what we get. Let's see, negative 2x squared plus 6x, wait a second, 0 pair is equal to 0. Okay, in a situation like this where there's no constant, it actually makes sense for us to see, can we factor out our coefficient, and can we factor out one of the x's? So the first question becomes, what can both of these things be divided by? Well, they can both be divided by negative 2. And since this has two x's to give up, and this has one x, we could steal an x from both of them. Let's see, we could write it like this. Negative 2x, parentheses, and negative 2x squared divided by negative 2x would simply be 1x. And 6x divided by negative 2x would be negative 3, is equal to 0. Now notice this, because this x value is outside of the parentheses, it's being multiplied by everything, we can actually just set this automatically equal to 0. Like, really humor me here. If this x was equal to 0, 0 times anything is going to be equal to 0. Well, that's pretty easy. Now here in this factor, we have to account for that negative 3 because it's x minus 3, and we just say, what is the opposite of negative 3? Well, that would be positive 3. Okay, let's see. Are we good so far? Well, I look at this point right here, and I notice that its x value is 0. And I look at this point right here, and I notice that its x value is 3. Okay, so far so good. And let's go ahead and let's try out plugging these things in. Obviously, our linear function is this. F of x is equal to negative 2x plus 3. And in fact, I have the room here Now to write it twice, f of x is equal to negative 2x. Oh, not negative 2x, negative 2 parentheses plus 3. And let's go ahead and plug in our x values. We know x value number 1 is 0, and we know x value number 2 is 3. And let's just go ahead and work through this. So we can say, f of 0 is equal to, well, negative 2 times 0 is 0, plus 3 is just 3, and our point is 0, 3. Does this check out? Yes, it does. All right, how about right here? Well, we would say, f of 3 is equal to negative 2 times 3 is negative 6 plus 3. And of course, that would give us, let's just kind of skip to the end here, 3 comma, negative 6 plus 3 is negative 3. And 3, negative 3, does that work out? And the answer is yes. All right, I hope this helps, and I'll catch you guys in our next video.